Thank you very much. Thank you for the invitation, dear colleagues. Imagine having an access to millions of documents, actually made publicly available 4 million documents from the public archives of the Parliament, and spanning 7 decades of European political history. These debates tell the story of the European Parliament's evolution, debates and decisions since 1952. Now imagine doing so in any language, even if these documents were originally written in French, German, or another language you may not speak. Thanks to advances in generative AI, this isn't a distant dream now. That's what we made, and that's reality. As head of the European Parliament's Archives Unit, I'm excited to share how we are using cutting-edge AI technology to make these archives accessible for everyone, regardless languages or locations. The European Parliament's public archives hold invaluable records, debates, decisions, reports that document the evolution of the Union. These archives are more than just an historical resource. They open a window onto the legislative processes that shape the Europe we know today. With over 4 million documents, accessing this wealth of information was once a huge challenge. You needed specialist knowledge, language skills. But today, we are transforming how the public can interact with these archives by harnessing AI, making this treasure trove of information available at the click of a button. If data is the fuel of AI, it must first be properly prepared for AI algorithm to use. In our system, we don't handle individual documents, we work with fonts. A font, as you know, as many of you are archivists, is a collection of documents that naturally originate from the activities of a specific agency, person, or organization. Once a font is processed by archivists, manually processed by archivists, we upload all these documents, if they are public, along with their metadata. Metadata includes details like the document type, the reference number, file names, title, and creation year. Next, we divide each document into overlapping chunks of over 300 tokens, words and characters. Each chunk is then converted into an embedding, which is a numerical representation of the text. We use the solution which is Cohere embedded, multilingual model, to create a 1024 dimensional vector for each chunk. Finally, we store and index the metadata, the text chunk, and its embedding into our database using the solution OpenSearch. So it's important to understand that whatever you want to do with a solution, you will have to prepare the data for this solution to consume your data. It doesn't come from free. That's a huge effort. At the entrance, as it has been shown, we have fonts that has been selected because they are publicly available, mainly, or they are in agreement with the treaties for the transparency, or they are in agreement with the regulation 354, 1983 about the opening of public archives to citizens. All these documents has been manually controlled, one by one. All the 4.2 million documents. How did we do that? I took a wonderful opportunity of an event that was less wonderful for many people called COVID-19. During the COVID period, we couldn't go back to the offices, but we were lucky enough to have an access to the archive management system. So we could remotely control all the data we had. So we started back from 1952 onwards, and we control each metadata we wanted to publish. Each document we wanted to publish, is it correctly scanned? Is it scanned? That it exists? Is the metadata correct? And for the one that we had to rescan, we made a list, and when we came back to the office, we scan again the document, and we place it into the archive management system. During this overall period of the COVID, all the archivists from the unit worked on a quality control of the archive management system. The first one we had about the Common Assembly and the ad hoc assembly were up to 20% of issues. One issue could be missing documents, missing scanned document. an error in the title, wrong date. We very often accuse machines for making errors because they do not provide a complete answer, but we also forget that sometimes as a human beings we are also making errors. It's very easy when you have a document from 1999 to put 1990 because 0 is closer to 9. You will not notice it, except if you have a change of parliamentary term in between, for which when you search for a specific term, you find a document for which the creation date has nothing to do with a corresponding period, and then you realize that's an error. Or having documents from 1900, which obviously for the European institution is a little bit early in time. So all these data were controlled by human beings, prepared, extracted, ingested, and then we put inside our repository, which is basically a database that we index with OpenSearch. On one side, each of the chunk. So we do not index all the documents. It's important. We index the chunk, the overlapping chunks that we created from the document. We store them into the database. We take the metadata and we take the embedding. So both text, embedding value, and metadata. It's important because you will see that in the next slide on how we use it. Another point is about multilingualism. When we are talking about multilingualism, we have to work with 24 languages. In fact, we work with more than that. I think we have a colleague from Japan in the room. We'll see later on how we address Japanese. We are in Wales. We'll see how we address Welsh. So it's more than that. It's not just 24 official working languages. We went over this limit. So initial documents were made in the languages from the first countries that created the European community. Basically was Dutch, German, French, and Italian. We only had 4 languages. Nowadays we have 24. But how do you want to address a document? In the Slovenian version, for instance, if Slovenia was not part of the first countries that created the European communities. In this case, multilingualism may have been an issue. So we decided to choose one of the languages that was there from the very beginning and also all the metadata available in this language. So we took French. So we index all the documents in French. And that's also important for what will happen just after on the way we use it. Because we want to provide an access to all documents in any languages, we need to have at least or one language for which we have all the official documents, or to translate the documents in all the remaining languages. But imagine if you want to open your documents to Japan. What will you do? Will you translate all your corpus in Japanese? Well, maybe quite complex. So that's a choice we made. It's a choice. We can criticize choices, but sometimes we make choices. So we decided to take one language, French, and index all the documents in French. Why didn't we take English? Well, England was not really part of the European communities in 1952, obviously. Yeah. So that's why we did that. And why French more than German, Italian, or Dutch? Because the large language models were highly trained in English and French, less in German. So this is the reason why we went also to French. So at the heart of our AI system is a powerful technique called Retrieval-Augmented Generation, or RAG. Let me explain how it works. First, we retrieve only the relevant European Parliament document for your query. A context retriever is responsible for selecting relevant information from the collection of documents proposed in response to a user query. The context retriever integrates keyword-based search, and this one is based on name entities to perform a keyword-based BM25, which is the best match 25 search using the OpenSearch solution. And in the same time, with a vector similarity search, which is the key NN, so the nearest neighbor algorithm that we used, based on a cosine similarity using the CoAir embedded model. The 10 best results are retrieved from the keyword-based search. The 20 best documents are retrieved from the semantic search. The 30 best documents are merged and followed by a re-ranking stage to optimize the relevance of retrieved chunks. The maximum 8 base documents with a re-ranking rate superior to 0.4 of the highest score are kept. So how do we establish that? As I mentioned before, we took French as being the version for which we index all the chunks from the document. So you place a query. Query is a question. You place a query, and then first thing we check, is the query in French or not? Because it was indexed in French. If the query was not in French, we translate the query in French. And this is how we will use the BM25. Because the BM25 will try to look for metadata and chunk. So we will try to look for the indexes. So we have named entity recognition. So we try to look for location, person, organization, so on, dates. And then we try to look for them into the textual information, which is a chunk or metadata. We extract the relevant document we find. Then in parallel, we are using an embedded model. And we are using COER, multilingual version, so that we check the correspondency between the floating numbers into the vector. This one is language independent. But because we want to increase the relevance of the document we retrieve, we are performing both search into metadata and chunks in text with the named entity recognition, and in parallel, the multilingual vector search on the floating numbers. Why did we do that? Because we noticed that we initially made only the first pass, 2024, but the result was not, let's say, sufficient in terms of quality to have something that you could rely on. Then we tried the second one, say, okay, it's interesting, but sometimes we are lacking some information because it's in the metadata, but the chunk will not retrieve it. And then we say, okay, let's mix both. We check both sides. On one side, metadata and chunks, and on the other side, the vector representation. We retrieve them. So we have potentially a maximum of 30 documents, because sometimes we may have the same chunks that we retrieve. So we have a maximum of 30. We take the highest value for the re-ranking. If the re-ranking has a value of 3, we multiply by 0.4, meaning 1.2. We take the 8 top documents and we remove all of them which are less than 1.2. And this creates the relevant set of chunks that then we will transfer for the large language model. Because this is what we estimate as being the context created on which the large language model will have to build an answer. These documents only come from European Parliament acknowledged sources. So we trust the original documents. We try to process them in a way that we have an efficient selection of the chunks that could be relevant to answer to the question. What we receive, the large language model, is a context. So the context is not a set of documents. The context is a set of chunks. It receives a query, and it also has the hypertext parameters. And what are the hypertext parameters? These are all the parameters that you set in order to define the behavior of your solution. In our case, for instance, we move the creativity of the solution to 0. So it's a floating number from 0 to 1. 1 is very creative, 0 is absolutely not creative. This is called temperature. We set the temperature to 0. Why? Because we want this behavior to be considered by the archivist, by historian, by librarians first, and eventually by citizen if they want to access. In this case, no historian, no archivist, no librarian will trust a secondary source. They will always go to the first source, not the secondary one. So there's no reason to make a lot of creativity. There's no reason to make poetry. What we want to have is facts, documents, proof on how you retrieve information. So that's the reason why we kept this information. So the hypertext parameter, the query, and the context. In addition, it's not a robot, it's not a soft bot, so it's not a chatbot. You cannot refine a query. This is voluntary. There are many questions, as you have seen maybe in the press with character AI or other solution, by which you could have an habituation to a solution. People will try to establish a relationship with the system. That's another debate we may have. But if something responds to you and you can refine, you will install a relationship. We know that for a very long time. I was publishing things on these topics more than 30 years ago. But we don't want to have this potential relationship being established, especially that we do not check whether there are minors or not using the solution. So it's only a one shot. So it's a zero-shot solution. And no information sent to the system, the query, or the answer is reused to train or fine-tune the solution. Everything is forgotten. That's also for privacy. We do not check the sessions, we do not check the queries, we do not check the answers, we just provide the information. So, the solution. Let's imagine that you have a question and you are placing a question on, do you have information on the Amsterdam Declaration on the architectural heritage in 1975? So this is the kind of answer you will have. So what do you have? You have the text that corresponds to your answer. Each of the sentences which is used is justified by the presence of the document. Each of the documents are provided below. What we have are all the versions, all the linguistic versions of the document we have. Could be go to 4 to 24. And then when we expand this information, we have a set of parameters and a set of metadata that we provide. So let's go to a real case system. So this is a dashboard that we are using and the 4 million document that we are exposing currently. We have a set of other discriminative AI algorithms that we implemented before in order to have automatic Eurovic indexation, for instance, or automatic summary, or automatic distance calculation between documents. That's another topic of exchange. But if we move to the solution that we implemented for AI, I think this question could be pretty interesting. Yeah? So let's see what this gives. So the time to process is around 20 seconds, more or less, is the query. So it goes through all the steps. One of the quite consuming steps is the one for translation that we just introduced. So if you don't have this translation from the query to French, it's around 7 seconds. But the addition of the translation is using quite a lot of resources. So in average, this is the kind of information you have. As you can see, we provide the information on which document set you could use. And we very clearly state that this is an AI system. And of course, by being an AI system, and a generative AI system, it doesn't represent an official stance of the European Parliament, right? So you don't need to go to the disclaimer. It's clearly stated from the beginning that when you place your query, this one will be generated by AI. And this is the answer you have. It's factual, no poetry, as I said before. So you've got the sentence and which document is supporting the generation of the sentence. For each of the documents, we've got a language that we can retrieve. So let's say that we want to see the English version of the document, and you have a digital access to a document you can download if you want. And you can expand, and by expanding, you see the metadata from the document, so the year, the type, the title, the reference if you want to request for a copy or an original copy or a different copy of the document, and also the source. The source is a chunk that we use in the indexation system to retrieve the information. So the presence of this chunk is the reason why this document was selected corresponding to your query. And you can go through all the documents that you want, and you see sometimes that you have various types of documents. Of course, we are in Wales. I think, do we have people in the room speaking Welsh? Yeah, 1, 2, 3, 4, 5. That's all? No, 5. Yeah. Please, I will ask you just to check whether the answer is correct in Welsh or not. That's your contribution. Yeah? Oh, thanks. So I will not kill the solution this evening. So that's correct for the document. Of course, you retrieve the same information, the documents, the chunks that you can retrieve. We do not translate the documents because this time it will request an official translation. because these are official documents from the European Parliament. But at least you have an answer in your own language. If you want more, you can download the documents in the version that you may know. So we don't know if you speak Welsh and Italian or Welsh and German. In this case, you choose a second language that would be the one that you will access the document and have an access to this one. I think that we also have a colleague who is coming from Japan, somewhere in the room. I saw him this morning. So similarly, so that's the first query. So what we index mainly are all the legislative documents. It's to represent all the activities from the Parliament. So we have the reports, the debates, the oral interventions, but also parliamentary questions and resolutions. So it corresponds to a coherent set of information that we index. And this is the information we retrieve for the relationship with Japan. And as usual, all documents are placed below. Great. But not everybody in Japan is speaking English. So I don't know where the colleague from Japan is, if he can raise his hand. Yeah, hi. Could you please check? If the solution provides an appropriate answer, then it will survive the day. Otherwise, we have to kill. We can kill a solution. Yeah, that's something we can do.
Yeah, that's right.
Okay, thank you. So you will be able to test the solution afterwards, so it will be still alive. So for teacher and researcher, this opens up a new horizons. Universities across Europe and beyond can now integrate the European Parliament's archives in their curricula, allowing students to explore the history of the Union in their native language. Researchers can conduct in-depth analyses, compare legislative trends, and track policy developments over decades. And they can do all this without the need of specialized language skills. But it's not just universities. This AI-powered access fosters greater transparency and civic engagement. European citizens, journalists, and policymakers can now interact with primary documents in ways that were once available only to a select few. This helps strengthen democratic accountability by providing a window into decisions impacting millions of lives that has been made over the years. Beyond technology, these AI solutions plays a deeper role. It serves as a bridge between the past and the present. When we think of archives, we often imagine them as static collections, boxes, and dust. Very often. But with RAG approach, we actively bring history to life. It's no longer a passive collection of documents. Now users can interact with the data as complex questions and receive meaningful and contextual information. The system not only preserves the legislative memory of the European Union, but also helps us learn from the past to inform on the present and the future. Of course, none of this would be possible without collaboration. AI does the work of retrieving and generating information. But it's a human input, archivists, historians, or legal experts, that adds richness and context. While AI can interpret patterns and connections, it's up to us to ask the right questions and interpret the findings. This collaboration between human and artificial intelligence allows us not only to access history, but also to draw meaningful insights from it. Let's try two different queries. Do you have documents describing the relations between the European Parliament and Australia from 1979? Or retrieve and list documents detailing the relations between the European Parliament and Australia from 1979 onward, include resolution, debates, reports, official statements, and legislative actions covering political, economic, and diplomatic access. Highlight key agreements, parliamentary discussions, and significant turning points in their relationship. You can notice a difference in the answers based on the additional contextual information provided. In conclusion, the European Parliament's archives offer a living testimony to European democracy. With our AI-powered solution, we are making this history accessible, multilingual, and interactive. This isn't just about convenience, it's about ensuring that every European citizen, researcher, and student can engage with European history without barriers or limits. We are opening up history in a new and exciting ways, and I invite you to all explore it. Thank you.